Hi there. Now here we've got a question where we've got to transform this differential equation into this differential equation using the following substitution. So if you'd like to have a go at this, haven't had a chance to do it, I'll just give you a moment to pause the video, and when you come back, as usual, I'll take you slowly through the work solution. Okay, welcome back then if you had a go. So what we've got to use then is the substitution here. So let's just start with putting that down. V equals y to the power minus 3. And what I notice is that in the equation that we've got to prove, we get a hint of what we've got to do. There's no y's here. So that means that we're going to need to find dy by dx. So I need to differentiate this with respect to x. So let's just put this down that we'll differentiate with respect to x. So it means we're going to need to use implicit differentiation. Differentiating v with respect to x is therefore going to give us dv by dx. Differentiating y to the power minus 3 with respect to x, we differentiate it with respect to y and get minus 3y to the power minus 4. And then multiply it then by dy by dx to complete that differentiation. Okay, so we now need to make dy by dx the subject. So if I rearrange that, dy by dx is going to equal minus y to the power 4 over 3, and that's multiplied by dv by dx. So I'm going to have to call upon this equation here and this equation here at some point. So let's just number these equations here, 1 and 2. And let's just section this off and then say sub equation 2 into this one here, okay? Now, what's that going to give us? Well, we're therefore going to have x times dy by dx, so it'll be x times this, giving us minus x y to the power 4 over 3 times dv by dx. And then let's just leave the y's in, okay? We've got plus y equals 2x to the power 4, y to the power 4. Now, what I notice then is we've got, as I say, we've got these y's in. We don't want any y's. The only way we're going to be able to access the y's is through equation 1 with y to the power minus 3. So if I was to divide through by y to the power 4, obviously it would go from here and here, and it will leave me with y to the minus 3. So what we've got then is, let's just put a note here, divide by y to the power 4. I'll do it in just slow stages, okay? So therefore we've got minus x over 3 dv by dx plus y to the minus 3 equals 2x to the power 4. And then if we substitute what we have in 1, let's just put that in, sub 1 in, and we call this equation 3 in 3, then what we've obviously got now is minus x over 3 dv by dx plus v equals 2x to the 4. I'm sure you could have got down there much quicker than what I've just done. Now clearly all I need to do now is just get rid of minus x over 3. So if we were to multiply through by 3 and divide through by negative x, then we therefore have what we needed to prove. That is dv by dx minus 3v over x equals minus 6x cubed. Okay?